everyone, Basil here with another exciting video about Cosmos Lab. So today's lab, it's a science lab and you can find it under grade 6 and 7. You can scroll down to AM, FM modulation and the lab is there with all the relevant documents. You have the description of the lab and the lab itself. Today I'm going to talk about the flow of the lesson or the flow of the unit, in fact. So this is a teacher's guide. You have your lesson plan. You have your lesson plan with all the details, lessons, instructions. So what is this lesson about? So this lesson explains the relationship between the size of the wave and the frequency. And it explains the relationship between the wave's energy and the wave's length, among other things. So this is a perfect guide for teachers. So you go and look at the lesson plan. It has all the details and instruction on all the activities, including the lab itself. Next thing you have to look at is the Cosmos experiment. This document explains the experiment step by step. It gives you the instruction what you need to do, what the students need to do, what materials you need, and how you need to conduct the experiment. So you take a look at this document. If you want, you can share this document with your students as well. Then you should start this unit by introducing electromagnetic waves to your students. So before we do the experiment, students need to understand what are electromagnetic waves. So this PowerPoint explains what are electromagnetic waves, what is a wavelength, how does a frequency affect the wave, and where do radio waves sit on the electromagnetic spectrum. So this PowerPoint will explain the entire range of electromagnetic spectrum, and it's directly related to the experiment. It includes a lot of images, videos, background information, and some relevant questions that you can ask. It talks about the visible light, it talks about the ultraviolet, X-rays, the whole spectrum, including radio waves. After this, students have a sense of what are electromagnetic waves and where do radio waves sit on the spectrum and why are they relevant. You can introduce this background reading to the students so they have a foundational understanding of why this experiment is relevant, or why are we doing this experiment and how does it affect my life. So this background reading provides more images and information to students to fill in the gaps that it might have in their knowledge. After this reading, you can have a small class discussion, or you can have a small group discussion where students talk to each other in a group of 4 to 5 students and discuss this document and maybe write a little reflection. After that, the actual day of the experiment, or the presentation of the experiment, comes in. So this PowerPoint is a step-by-step guide to what are radio waves, what is an AM, FM signal, and how we can capture it, and how does it look when we see it on the experiment. So students start out the day with a small little do now, using their background knowledge, and having a little review. They go into this short video about what is electromagnetic spectrum. So if a student missed yesterday's class, they can catch up. Again, reinforcing our knowledge and introducing new knowledge at the same time. So this is going deep into what are radio waves, images, and then what is AM, what is FM, what's the difference, what are the similarities, and where would you use AM frequency, where would you use FM frequency, so on and so forth. This introduces some vocabulary words as well: amplitude, amplitude modification, frequency modification, signal, curve wave, carrier wave, sound wave, and so on and so forth, including some particular images about AM and FM. So students will look at these images and we'll have a class discussion as you're presenting this information. So other information you're presenting in this PowerPoint is about a wave length. You know, what is the resting position? What is the time or distance? What is the crest? The materials you need to conduct this lab. You know, obviously you need the COSMOS Educational Toolkit. You need a computer monitor. You need the Pluto SDR, and you need the antenna. So you go on to the COSMOS Toolkit, you click on the icon, and you start the experiment from there. And there will be a separate video explaining the experiment. So then students, you know, do a little reflection after this PowerPoint so they can solidify their knowledge. You go into the rules of the experiment. How is the experiment conducted? You know, you can include up to 5 people. They don't have to be 5 people in a team, but you can include up to 5 people if you have a bigger class and you want to do few experiments. So you have a team leader. All the students are leader. This is just the roles to assigned to keep the students on task. You have the tech manager. You have the scribe. You have the noisemaker. And after the experiment, while the students are doing the experiment, obviously they take notes and they have something to look back onto, and then they do a little reflection by, you know, describing what the experiment was about, what was their finding, and why is it relevant. So they go on and do this reflection, and you know, then everybody does the experiment. You come back to this slide where it connects to their life, like why is it relevant to my life, and why are we still talking about radio waves? You know, we're living in the era of 5G, but why are we still talking about radio waves? So you have a little class discussion about that, and then you answer any questions that the students might have. After this activity, you move on to this document. While you're presenting this, students with special needs can use this document to take notes so they don't have to copy every word that you say, but they still have the relevant information. When they're reading the background information, you can just give them this document. So this will help guide their thinking, not just the student with needs. You know, you can give to your students that might need extra time, students that might need a revision. So you can give this document so they can take on notes and follow the lesson along with the rest of the class. Then you come to a vocabulary activity. I always believe that if you don't understand the terminology around a discussion, you won't understand what the topic is. So this activity, you basically match the word with its definition, and then you ask the students to explain the word in their own words. There's another activity, it's like a crossword puzzle where they have to fill in. So depending on which students, you can you know, differentiate. Some students might do this vocabulary activity and others might do this vocabulary activities. It's all up to you. The lesson is very differentiated. Then we move on to the assessment part. You can use this document as you know, summative assessment, or you can just use it as a benchmark, you know, as formative assessment as well. This is up to you. So this will ask simple question about the experiment, and it will review or give hints to students what they need to do. And this also includes the notes that they're taking while they're conducting the experiment. So they can submit this to you as their finding as well. It's a very comprehensive document, so you can also do your edits, add things, take out things. It's all completely up to you. And the whole experiment is designed as a flexible experiment where teachers can pick and choose and see what works for their class and what does not work for their class. So this was the overview of the lesson AM/FM signals from a microphone. This is Basil signing off. Until next time. Thank you.